This is part 2 of the homework video guide where we need to find the derivative value at the given point, and the given point that I have is 2 comma 2 for this question. Now I've gone ahead and picked a few of these square root problems for the homework because you have to be very good at changing a square root to a power, more likely a negative power, and then changing it back to a radical, right? So that's a very good skill that students need to know for this particular problem and throughout this course. All right, so I will not write the d over dx step. I will go ahead and start simplifying this. So let's just change everything into a power first. So this is minus 4 bracket xy to the power of 1/2, and that's going to equal to negative 6. So that's step number 1. We will write everything as a power, and as mentioned, I'm going to skip the d over dx step. I will go ahead and start taking the derivative right away. I will start over here with the power of 1/2. That gets soccer kicked to the front, so 1/2 in front. And then I have brackets, everything on the inside remains the same. And then the power gets decreased by 1, so 1/2 minus 1 will be negative 1/2. And then the chain rule states that you need to multiply by the derivative of the inside, right? So the derivative of the inside will be 4 minus 2y times, I'll put this in blue here for the y prime. Okay, so there you go. There's the first part for the derivative. And then we have a minus sign, and now we're moving on to this part right here of the problem, this middle term, sorry, the minus 4 bracket xy to the power of 1/2. All right, so if I apply the power rule here, this 1/2 gets multiplied with that 4, so I have a negative 2, so negative 2, and then bracket xy, and then close the bracket, and then that gets raised to the power of 1/2. Okay, and then from there we need to use the chain rule here, and we need to multiply by the derivative of the inside here. So the derivative of the derivative of xy, we need to use the product rule, right? Okay, so if I just open up the brackets here, the derivative of x is 1, and so I have 1 times y plus x times the derivative of y, which is y prime. And then I close that bracket, and then finally that's going to equal to the derivative of negative 6, which is 0. Okay, so that's our derivative right there. So that was quite long, and a very long horizontal line of algebra work there. And what we need to do now is, let me kind of erase this top line here. And as I mentioned, the point that we're looking at is the point 2 comma 2. Okay. So what this means is that every single x value, all the x's that you will see in this problem get changed with 2, and all the y values will be changed with 2 as well. All right, so instead of isolating for y prime, let's go ahead and just plug in the values if we can here. So I have a 1/2. All right, close the bracket, and then I have a 4x, but x is being multiplied by 2, right? So 4 times 2 is going to be 8. Minus, and then what's y squared? Well, y is 2, and 2 squared is 4, and that's being raised to the power of negative 1/2. And then 4 minus, and then 2 times, well, the value of y is going to be 2, so 2 times 2, and then times it by y prime. Close the bracket, and then I have a minus 2 here, and then inside the brackets here, it's really x times y, so 2 times 2 is going to be 4, right? So 4 goes in that bracket, the power of negative 1/2, and then times it by, over here I have 1 times y, so y is 2, so 1 times 2 is 2, plus, and then x here is 2, so that's going to be 2, and then the y prime remains, so 2y prime, and then I close the bracket, and that equals to 0. Okay, so still quite a bit of work there. Let's see if we can just simplify all of this now. Okay, so let's go ahead and now compute the numbers and try to clean this up. Let's go back to the beginning now. So let's take care of this part right here. So I know 8 minus 4 is going to be 4, and that's being raised to the power of negative 1/2. And I know this equals to 1 over the square root of 4, and 1 over the square root of 4 is going to be 2, 1 over 2. Okay, so let's go ahead and erase this part here, and we are multiplying this by 1 over 2. And I know that 1 over 2 times 1 over 2 is 1 over 4. So I'll erase all this now, and this will be 1 over 4. Okay. Then if I keep on trucking along here, let's take a look at this 1 over 4. And this 1 over 4, it can just distribute. Actually, before I distribute this, we know that 2 times 2 is going to be 4, right? So I can erase this, and I'll put a minus 4 there. And then I know this 1/2, if I distribute that in, what we have is 1/4 times 4 is going to be 1 minus, and 1/4 times 4 again is going to be 1 times y prime. Okay, and then let's keep on moving along here. Then I have 4 to the power negative 1/2. So we kind of talked about that already, right? That's the same thing as 1 over the square root of 4, which is equal to 1/2. So if I erase all this, I know that's going to equal to 1/2. And if I take this 2 and times it by the 1/2, I get just a minus sign, right? So that just goes away. And there's a minus 1 there, I guess. So let me kind of clean this up here. So minus, and then a 1, and then a open bracket here, and then I have a 2 plus 2y prime, and then I can close the bracket, and that equals to 0. Okay, so this is looking a lot better, and if I go back to this first term here, I guess you can just remove the bracket, so I can remove that bracket and remove that bracket. If I go ahead and distribute this into the brackets here, I get a negative 2 minus 2y prime equals to 0. I got 1 minus the y prime here. Okay, so this is looking pretty good now. I have a negative y prime and a negative 2y prime, so that's going to be negative 3y prime equals 2. And then this negative 2 will come over as a positive 2, and this 1 will come over as a negative 1. And if I keep on going here, I have negative 3y prime equals to 1. And if I simplify here, y prime would equal to negative 1 over 3. All right, so that's the answer for that particular question. Definitely a lot of steps to go through when you're finding the derivative value there for these implicit derivative questions here. Okay, so move on to the next one here. So for this question 2, I need to find the derivative value when we're at the point 4 comma 2. So we can start off by writing the d over dx. I didn't do this for the other problem, but that's fine. We can do this for this problem here. And before we take the derivative here, we should rewrite this as x equals to y squared, and then bracket y minus 1 to the power of 1/2, and then we can close the bracket there. Okay, so now we're ready to take the derivative here. The derivative of x is going to be 1. So 1 would equal 2, and then we have a product rule on the right hand side, so the derivative of y squared is going to be 2y times y prime, and then we multiply by the second term, which is y minus 1 to the power of 1/2, and then we add that to the first term, which is going to be y squared, and then we multiply by the derivative of the second term, which is this part here in green. Alright, so if I multiply by the derivative, I get the 1/2 in front, and then the y minus 1 remains to the power of negative 1/2, and then we just times by y prime. Okay, so that's looking pretty good, and let me just kind of erase this now, and basically what we need to do is we need to find y prime at the point 4 comma 2. Alright, so let me kind of write this in bold letters here, 4 comma 2. Okay, so let's see if we can do the math in our head here. We have 1 would equal 2. Okay, so I have a 2 here, and then this y is going to be that 2. So 2 times 2 is going to be 4, right? So this will be 4y prime, bracket on 2. Okay, next step, I guess this y is going to become a 2 there, so 2 minus 1. 2 minus 1 to the power of 1/2. And 2 minus 1 is going to be a 1, and 1 to the power of 1/2, well, 1 to the power of anything is going to be 1, so I can get rid of this, so 1 to the power of 1/2 is going to be 1, so I can erase that, plus, okay, so as far as I'm concerned, this is all done now, we've computed that, plus, and then y squared is going to be 2 squared, which is going to be 4, times 1/2, and then bracket 2 minus 1 to the power of negative 1/2, and then we times that by y prime. Okay, let's see if we can do the math again here. So 4 times 1/2 is going to be a 2, right? So I'll erase that, and then we have a 2 here. And then this part right here, you got to be able to do that in your head. 2 minus 1 is 1, and 1 to the power of anything is always going to be a 1. So if I erase all this, that's going to be 2 times 1, and then times it by the y prime. Okay, so this is what I have here. It's a bit out of space here, so I'll put 2 times 1 is 2, so I guess I have a 2 y prime over here. So we did all those calculations mentally here, and now we're ready to kind of finish off the problem here. This would be a 6y prime, 4 plus 2 is 6, and y prime would equal to 1 over 6. All right, so that's a very good mental thinking exercise there by putting the numbers into the expression and doing the mental math in your head there. Okay, let's finish off this homework video guide by going over a few tangent line questions here. So I'm at the point 1, 3. I'll worry about that at the end, but let's go ahead and write out the derivative steps here. So I need to take the derivative of x squared plus y squared equals to x plus 3x squared y, and I'm going to close that bracket, and we're looking at the point 1, 3, right? The tangent line at the point 1, 3. All right, so let's go ahead and take the derivative here. So x squared is going to be 2x plus, and then the derivative of y squared is 2y times y prime, and that's going to equal to, well, the derivative of x over here is going to be 1, so 1 plus, and then we have a product rule here, right? So this right here is a product rule, right? So that's going to be 6x times y plus 3x squared times y prime. Okay, so and just like in the previous exercise here, we won't move anything around, and let's see if we can actually calculate the derivative value at the point 1, 3. So this is another mental math exercise here. So 2x, right? So 2 times 1 is going to be 2 plus, and then this y is going to be a 3, right? So 2 times 3 is going to be 6, so 6y prime equals to 1 plus. Okay, and then if I take this 1 and that 6 and this 3 and that y, that's really like 6 times 1 times 3, which is going to be 18, right? So 6 times 3 is 18 plus, and then this x is going to be a 1, so 3 times 1 squared is going to be 3y prime. Okay, so quite a bit of math going on here. I have 2 plus 6y prime equals to 19 plus 3y prime. If I bring the 2 over, I get a 17 and a 6y prime minus 3y prime. That will be a 3y prime equals to 17, and a y prime would equal to 17 over 3. All right, so that's not too bad. And if I go back to my point was 1, 3, right? So this is at the point 1, 3, right? So in order to kind of finish off your tangent line, you would write y minus 3 equals to 17 over 3 bracket x minus 1 as your tangent line there. Okay, so not a bad problem there. Another good mental math exercise there to finish off that problem. I would say for this homework video guide, this next question is a bit long in terms of the algebra here. So we're given this function, and we need to find the points on the curve where the tangent line is vertical, right? So we haven't done one of these vertical tangent line questions here, so we'll do that over here. So step number 1, we need to take the derivative of the expression that's given to us. So a lot of times in chapter number 3, if you're asked to find a tangent line or a normal line or something else, you can always start off by taking its derivative, right? So right here we have the product rule. So this is going to be 2x times y plus x squared times y prime. And then I have a minus sign, and I will put this in a bracket here because we have another product rule here and there. Okay, so if I apply the product rule here, that's going to be 1 times y cubed plus x times the derivative of y cubed is going to be 3y squared times y prime. I can close this bracket off, and then the derivative of 6 is going to be 0. Okay, so that's looking pretty good. So this is a different question. It's not like we're finding a derivative value or a tangent line here. So we need to go ahead and execute the algebra steps here. So this is 2xy plus x squared times y prime. And then minus, so this minus sign will now distribute into the brackets here. So minus y cubed, and then minus, okay, so if I kind of rewrite this, this is really the same thing as 3x y squared, and then times it by the y prime. And that's going to equal to 0. Okay, so our goal is we want to isolate for y prime, so we can write this as x squared times y prime, and then minus the 3x y squared times by y prime, and I'm going to take the 2xy and the negative y cubed, and I'm going to move that to the other side. If I move the negative y cubed first, I get y cubed and then minus 2xy. Okay, and then from there I can factor out the y primes, so this will be y prime bracket onto x squared minus 3x y squared, and then that equals to y cubed minus 2xy. And finally, sorry, not finally, but we're about 60% there now. We solve for y prime, which is y cubed minus 2xy all over x squared minus 3xy squared. Okay, so there is my derivative expression there. Now, what we need to do is we need to find the coordinates of the vertical tangent line, right? So find the points on the curve which the tangent line is vertical. Okay, if the tangent line is vertical, it means the slope is undefined, right? So the slope does not exist if you're looking for these vertical tangent lines. When you have a fraction, and if the denominator is equal to 0, then the slope is undefined. Okay, so sorry, this is your derivative, right? Okay, so your derivative in this case is going to be this fractional expression, and a fraction is undefined when the denominator is undefined. And if the denominator is undefined, that means the slope is undefined, and if you have an undefined slope, you have a vertical tangent line. Okay, so now we take our denominator here, which is x squared minus 3xy squared, and we make that equal to 0. Okay, then we apply a little bit of algebra here, so x squared equals to 3xy squared, and we notice that there's an x here and there's two x's here, so if I cancel out the x's, I now have x equals to 3y squared. Okay, so what do I do with this 3y squared? Okay, that's a good question. What we need to do now is we need to go back to the beginning here. And let me erase all this now. So make sure you have all these steps here. We know that the original question is x squared y minus xy cubed equals to 6. And we just found out from our previous step is that x would equal to 3y squared. Okay, so that comes from like this expression right here, right? X equals to 3y squared, right? So what we're going to do is we're going to take that 3y squared, and mathematically we're just plugging it back into the original equation to find the points. All right, anytime you want to find the points, you plug everything back into the original expression. Okay, so we're almost done here. So all the x's will be replaced with 3y squared. So this will be now 3y squared all raised to the power 2 times y minus 3y squared times by y cubed equals to 6. Okay, if I multiply this out, we have 9y to the power of 4 times by y minus 3y to the 5, right? 2 plus 3 is 5, right? And then equals to 6. And then if we multiply y to the power 4 with y, we get 9y to the 5 minus 3y to the 5 equals to 6. And erase all that. Alright, so we're almost done here. So 9 minus 3 is going to be 6y to the 5 equals to 6. And that means y to the power 5 equals to 6. And if I take the fifth root here, this means that y would equal to, oh sorry, I made a little mistake here. Just trying to rush this question now because I'm getting I'm just trying to rush this problem here now. Divide both sides by 6. And y to the power of 5 would equal to 1. And if I take the 5th root, then we know that y would also equal to 1. Okay, so great. Y equals to 1 there. And then we go back to over here. We know x equals to 3 times y squared. So that's the same thing as 3 times 1 to the power 2. And x would equal to 3. So our coordinate is 3, 1. So this was the y value, and this was the x value that we just found. Okay, so I kind of rushed the algebra steps on that last question there, but hopefully that's okay, and just rewind if you need to watch the homework video again.